Okay, Bismillah ar-Rahman ar-Rahim. We'll continue. Now, I think I need to do this problem. Yeah, this is related actually to the definition, but let me do it. First, let me make it. Okay. What's the meaning if it's continuous at x equal 2? Means limit x goes to 2 of f of x equal f at 2. Okay. And he said this limit equal to 5 or exist. So if you notice the limit in the denominator, t is using t, no problem. T goes to 1 in the denominator, that is 0. So for this limit to exist, I think we did something similar. I need the limit of the numerator to be equal to 0. Okay. This is just function, easy function. We can substitute. This is the same thing. So I need to think about f of 2t. So I need to think about this limit. Limit t goes to 1 of f of 2t. Okay, and I know this. This goes to 2 is equal to f of 2. Okay, so if I let x equal 2t, what will happen to this limit? It will be limit f of x. Now, if t goes to 1, x goes to 2. Which is this one. So that should equal to f of 2. So this as a limit should equal to f of 2. So that statement means what? Means the limit of t goes to 1 of t square, limit of t goes to 1 f of 2t minus limit t goes to 1 of 2t. This is should equal to 0. So this is will be 1. That will be f of 2 minus 2 equal to 0. So f of 2 equal to what they want. He want this limit x goes to 2 x f of x. This limit exists, and this limit also exists and equal to f of 2. So this is will be 2 f of 2, which is 2 times 2, which is 4. That's it. Okay, now let me move to this topic, types of discontinuity. Yes. If we look at these graphs, I think we'll explain everything. This function is continuous. I'm talking about x equals 0 in all of these cases. At x equals 0. This one, the function is not continuous. All the other cases, B, C, D, E, F, F is not continuous at x equals 0. Okay. So how many types of discontinuity? According to our book, we have 2 types, removable, and we call all of this non-removable. So we're talking the function is not continuous. Okay. When we call it removable, if the limit exists and the function not continuous. If the limit exists right away and we have discontinuity, we say it's a removable discontinuity. If the limit does not exist, if it is it will be not removable. If the limit does not exist, does not exist. Either because it goes to infinity or it's left not equal to right or oscillating, the limit does not exist. So if you look at this problem, there is a problem here. The function is not continuous at 0, but is it removable? The limit exists. We check the limit as x goes to 0 exists or does not exist. Exist. So this is removable. The same thing here at 0. The limit exists. Yes, the limit exists. So we call it removable. And this is what he meant. Maybe not defined, like in this case, at x equals 0, f of 0 is not defined. Or defined outside the range. It's defined, but not at 1, at 2. The other cases, D and E and F, the limit does not exist. D, E, F, for different reasons. So we say this is what? Non-removable. Yeah, some other books, they are talking about when the limit does not exist. If the limit if not equal to right, they call it jump. Goes to infinity, they call it infinite. Oscillating, they call it oscillating. But in our book, we say removable, non-removable. Okay. So that's what's going on in this case. By the way, why they call it removable? Because if you notice, if I redefine f at 0 to be 1, I make it continuous. So by small change, I make it continuous. The same thing. If instead make it equal to 2, make it equal to 1, I make it continuous. So I can remove the discontinuity easily by redefining another function, huh? But with just a little change. Okay, so if you look at this function, and I will not talk about jump and infinite. No, all of them I call it non-removable. Okay, look at this. The limit as it goes to 1. Will it exist or does not exist? That's the main point. The limit exists. Because you know this is x plus 1, this is 2, limit exists, so we call it what? Removable. Here, greatest integer of x, the limit does not exist. Limit is goes to 1 for greatest integer of x, does not exist. So we call it what? All of these three, they call them non-removable. Here, it goes to infinity or minus infinity, so it's not removable, the limit. It goes to either to plus or minus infinity, but the limit does not exist. This one oscillating, so the limit x goes to 0 in this case, no problem, does not exist. So if the limit exists, we call it removable. If the limit does not exist, we call it non-removable. If we have discontinuity. This is just examine the graph of those functions. So this is removable, and the other two are not removable. No need to go in details about infinite or jump, but it's not removable. Now we're going to discuss the continuity of each function. This one, very clear. I have f is not continuous at x equals 0. Why? It's not defined at 0. Is it removable or not removable? Check. Limit as this goes to 0 of 1 over x. Exists or does not exist? Does not exist. And it's infinite. It will go either to infinity or minus. From right and left, one of them goes from right goes to infinity, from left goes to minus infinity. So the limit does not exist. So we say it's non-removable discontinuity. Take the second one. At x equal 1, we have a problem, not continuous. At x equal 1. Why? Because it's not defined at 1. So check the limit. This one, we did it actually. I'm getting 2. So the limit exists. That means I have what? Removable discontinuity. Removable discontinuity. It's discontinuous, but it's removable. Look part C. I need to check. This is our continuous function, smooth one. Let's check the limit. It goes to 0 from right. And check it from left. Are they the same or not? And also I need to check f at 0. From right, are they the same or not? From 0, right of 0, I have this, e to the power 0, that is 1. Left, I will be here, that is 1. If at 0, substitute here, it's 1. So f is continuous everywhere. And the same thing with this sine, because sine I know the graph of sine. The function is continuous everywhere. Okay. Look at this question before I go to the old exams. I have a piecewise function where I have smooth functions inside. Okay. And he said find all values of k so that the function has removable discontinuity. Find all values of k so that the function is continuous at x equal a. I need to find the values of k. Okay. To check continuity, I need to check these three things. X goes to 1 from the difference at 1, huh? 1 from right to the equal limit is goes to 1 from left. equal f of 1. That is continuity. Limit is goes to 1 from right equals limit is goes to 1 from left, not equal to f of 1. That is removable discontinuity. So it means I need to check the limit from left and right. Are they equal? Then I need to compare it with f at 1. Okay, so I need to check the limit from right should equal the limit from left. I need this for both cases. That means what? From right, I will be here, substitute. You have k squared plus 1. From left, I will be there, substitute. You have 3k minus 1. Just like a quadratic equation, k squared minus 3k plus 2 equals 0. So you have k minus 2 times k minus 1 equals 0. So you have k equal 1 or k equal 2. Now, if k equal 1, what will be the limit as this goes to 1 for f of x with k equal 1? The right should equal to the left because I got the values for this one. X goes to 1 either from right or left. For k, if k equal 1, what will be the function? Let me write the function just for completeness. Let me write what will be the function. The function will be x plus 1 if x greater than 1, 2 if x equal 1, 3k minus 1 if x less than 1. 3x, I mean, sorry, because I have ups. I have 3x because I have k. K is 1. Okay. In this case, the function, is it continuous or not continuous? I need to check. Is it equal to f of 1 or not? So what is the limit? This goes to 1 for this function. Now, خلاص, I apply this k equal 1. What I have? From right, it will be 2. Should equal from left, but just to check. Yeah, it will be the same, 3 minus 1. And it's equal to 2, which is f at 1. So the function is continuous in this case at x equal 1. So if equal 1, I have what? Continuity. Okay, now let me do the same for k equal 2. Okay, k equal 2. What will happen? What will be the function? Let me put k equal 2. It will be 4x plus 1 if x greater than or less than. Not make a difference, greater than 1. And 3 if x equal 1. And what is the last one? K equal 2. Huh? So I have 6x minus 1 if x less than 1. Okay, so let me check the limit. It goes 1 from right or from left. From right. Is it equal limit from left? It should be. What will be the answer? From right, it will be 5. And that's the same thing, 5. So the limit, as this goes to 1, is equal to 5. What is f at 1? F at 1 is 3. They're not equal. So it means f has a removable discontinuity at x equal 1. If k equal 2. So if k equal 1, I'm getting the continuity. But if k equal 2, I'm getting what? Removable discontinuity. Okay, let me do all the examples. By the way, this yeah, I have removable and non-removable. Huh? Infinite, we don't have infinite. We call it non-removable. Okay. Okay. So this function, is it when I have removable, when I have non-removable? When we have discontinuity, we have discontinuity at the zeros of this one. So let me first simplify the function. I need grouping. That will be x squared, x plus 3, minus 9x plus 3 over x squared minus 9. And just I want to simplify the function times x plus 3 over x minus 3 times x plus 3. That give me what? X minus 3 times x plus 3 square, huh? Is it? Yeah. I have x squared, x plus 3 minus 9, x plus 3. Yeah. So x plus 3 square over x minus 3 times x plus 3. Okay. Now I need to check what are the points of discontinuity. Points of discontinuity. Very clear. X equals 0, x equals 3, and x equal minus 3. Yeah. I need to check the limit for each one of them. So if I do the limit, this goes to 0 for this expression. I have non-zero over 0. So I have infinity category. So it's either infinity or minus infinity. It depends from right or from left. So here, the limit does not exist. Goes to infinity or minus infinity, or does not exist. It depends on the sign. Okay. For 3, x equals 3, what will happen? What is the limit? As this goes to 3. This one will be cancelled. Substitute. I'm getting a number. 36 over 3 times 6, which is what? 2. So I'm getting a number. So the limit exists. The limit exists. That means what? This one, the limit exists. The limit exists. And the same thing for this one. If you do the limit, x goes to minus 3, you have what? X minus 3, x plus 3 square. I cancel this with this. You're getting what? Yeah, minus 6 over minus 3 times minus 6. And have here 0. So the answer is 0. So the limit exists. Limit exists. So we say here removable. We say here non-removable. So we have r equal to removable equal infinite. We call it non-removable. So this is my answer. So what I will do, I'll find the points of discontinuity, and then I will check. The limit exists, we call it removable. The limit does not exist, we call it not removable. Which is easy, just if there is a hole, then or the limit goes to infinity for these rational functions. So that will be x plus 2 times x plus 1, minus 2, sorry. Minus 2 and minus 1. I'm just simplifying the function. Here I have x minus 3 plus 3 times x minus 2. What are the points of discontinuity? Very clear. X equal minus 3, x equal 2. Here, the limit does not exist, will not exist, because I have non-zero. If I substitute, I have non-zero over 0. So for sure, the limit either infinity or minus infinity or does not exist. It depends from right or left. So we say non-removable. At x equal 2, these two cancelled. So I'm getting a number. So the limit exists. So we say it's what? Removable. Discontinuity. Okay. Same idea. At x equal 1, here I have if x equal greater than 1, this is less than 1, let me say, and this is greater than or equal to 1, something like this. So check the limit as this goes to 1. How to check the limit exists or does not exist? I'm not sure, but it seems to be what is here. Well, I don't know. Let me check. Limit is goes to 1 of x minus 1. So I will make the problem. Huh? Yeah. So this is x not equal to 1, and this is x equal 1. That will be the problem. So if x goes to 1, here it means left or right, and they are the same. So that will be what? This is cancelled. I have 1 over 2. But what is f at 1? That will be 2. Are they the same? No. So f is discontinuous at x equal 1, but the limit, this goes to 1, for f of x exists. There is a discontinuity because they're not equal to each other, but the limit exists. It means f has a removable discontinuity at x equal 1. So I have this. F has, okay. Yeah, actually, this is the question which we did. Huh? This one. When I say it's removable, when I say it's not removable, the same thing. I'll just simplify this. X minus 2, x plus 1. I have x minus 2 of x minus 1. So what are the points of discontinuity? Discontinuity points. X equal 2, x equal 1. This one, there is a cancellation. So I have number. So the limit exists. So it's a removable. And this one, still it will go non-zero over 0. So I have non-removable. Actually, it will be infinite, but we call it non-removable. So this is not removable. So at x equal 2, I have removable. At x equal 1, we have non-removable. The same idea. I have x squared, have x times x squared minus 1. So it's what? What are the points? I have x equals 0, points of discontinuity. X equals 0, x equal 1, x equal minus 1. This one will be removable because you can cancel this with this, so there is nothing here. So I'm getting a number which is 0, actually, which is okay, removable. But these two will be not removable because at x equal 1, I have non-zero over 0, and the same thing at x equal minus 1. So you have two non-removable and one removable. Let's call it non-removable. Yes. We call it infinite since it goes to infinity. Yeah. This one, there is an absolute value. So my concern is about x equal minus 2. Points of discontinuity is x equal minus 2. So I need to check the limit as this goes to minus 2. Yeah. So the thing for the absolute value, if x goes to minus 2, so x is negative. So this will be, for this function, regardless from right or left, because minus 2. Limit x goes to minus 2, 4 plus x times minus x over x plus 2. Now we do the calculation. You have what? 4 minus x squared over x plus 2. So that will be limit 2 minus x, x plus 2, or 2 plus x. Who cares? Over 2 plus x. So this is cancelled. So the limit exists. Actually, it's equal to 4. So the limit exists, but there is point of discontinuity. So we say it's a removable discontinuity. Same thing here. That will be x minus 1, over x minus 1, x plus 1. What are the points of discontinuity? Very clear. X equal 1, x equal minus 1. This and this is cancelled. So 1 I have removable. Since the limit exists, minus 1 I have not removable. I actually have infinite since it goes to infinity. So it would be like this. Sometimes you need to simplify the function. This is what? 1 over x minus 2 plus 2 over x minus 2, x minus 1. That will be x minus 2 times x minus 1. I have what? X minus 1 plus 2. Correct? So I have x plus 1 over x minus 2 times x minus 1. Okay. So what are the points of discontinuity? X equal 1 and x equal 2. Are they removable, not removable? The limit, if I take x equal 2, x equal 1, I have non-zero over 0. So I have non-removable, infinite actually. And the same thing for 2. I have non-zero over 0. So this is 2 infinite or 2 non-removable. The same idea. X plus 2, x minus 3. What are the points of discontinuity? X equals 0, x equals 3. X goes with x, so have the limit exists and it will be just a value. You have removable at x equals 0 and not removable at x equals 3. Actually have infinite. Infinite is x equals 3 and removable at x equals 0. I don't need the words infinite for this course. Okay, from the graph. Which one of the following is not true? F has a horizontal asymptote at y equal 1. True. It has a horizontal asymptote as it goes to infinity. Yes, correct. Has a vertical asymptote at x equal 1. Yes, we have a vertical asymptote. Jump discontinuity. We have at x equals 0, we have jump. Yeah. So this is true. Infinite at x equal 1. Still correct. The limit of f as x approaches 0 exists. No. This is wrong. This is not correct. Yeah. So this is the solution. This function, which is true about this function? Is it continuous? What we have continuity. Look, when you have something like this, you need to rewrite it. Because this is greater than 1 means what? X greater than 1 or x less than minus 1. This one, it means what? X between minus 1 and 1. So this function is what? This function actually, if x is less than minus 1, it is this one. If x between minus 1 and 1, it is x, it is this one. And now again, if x is greater than 1, it is this one. Okay. So is there a problem with the discontinuity at x equal 1 for the function before I go to these points in here, minus 1, 1? Here, things are defined because yes, x equal 1, there is a problem, but it's not in the domain. It's not in this interval. And the same thing here. So I need to check limit. X goes to minus 1 from right. And check, is it equal limit x minus 1 from left? Is it equal to f of minus 1? If these three are equal, then the function is continuous at x equal minus 1. If the limit equal but not equal to f of minus 1, then we say that we have removable discontinuity. Okay, let me see. X goes to minus 1 from right. Minus 1 from right will be here. So the answer is minus 1. Done. Now this one, is it equal limit? That's a question mark. X goes to minus 1 from left of this one. Minus 1 from left, that is negative, which is minus 1 point something. So if I put it there, I'm getting a negative value. So I take it out as a negative. That will be minus x minus 1 over x minus 1. That's equal to minus 1. So these two limits are equal. This equal to this. Now, what about f of minus 1? F of minus 1, you just substitute there, I'm getting minus 1. So f is continuous at x equal minus 1. Good. Now let me go to x equal 1. Do the same. What is limit? X goes 1 from right. Right, I will be here, so I need to do this absolute value things. Now if I put 1 from right, this will be positive, so it will be the same out. I'll take it as is. And the answer is 1. What is the limit? As it goes to 1 from left. From left, I will be here. That will be 1. So they are the same, and it's equal to f at 1. So the same thing, f is continuous at x equal 1. So it's continuous everywhere. Yes, in the full interval. Which one of the following function has a removable discontinuity at a? Yeah, at 1, I have a problem. Very clear. At 1, I have a problem. Yeah, it's not defined at 1. So I need to check what will happen. Is it the limit exists or does not exist? To say it's removable or not. Limit x goes to 1, f of x. That will be limit. This is I. This is the first one. Goes to 1 of x to the power 4 minus 1 over x minus 1. Yeah, this is, I can do it. X squared minus 1, x squared plus 1. Then I need to simplify it again. X factor it again. I mean, x plus 1, x plus 1. So what will happen? This is cancelled. Substitute, I have 2 times 2, which is 4. So the limit exists, so I have removable. Discontinuity. Okay. Now let me check 2. I need to check the limit. And this goes to y from right for this function. Yeah, and from left. What will happen? This is the graph of sine. Let me put it here. This is y. So if x goes to y from right, sine x goes where? Pi from right. Oh, sine x goes to 0, but from left. Less than 0 a little bit. So it will be the greatest integer? Minus 1. But if I put x goes to pi from left, I will be here. So sine x goes to 0 from right. So this gets into equal what? 0. So the limit does not exist. So the limit, as this goes to pi of the greatest integer sine x, does not exist. So f is discontinuous, but not removable. But the limit right not equal. So the limit does not exist. But it will be discontinuous. The third one, I need to check limit x goes to 1. Very clear, at x equal 1, we have discontinuity. Because it will be 1 minus 1, 0. So I have 1 minus x over 1 minus absolute value of x. As this goes to 1, either from right or left, this will be positive. 1 to the right, 1 to the left, it's a positive value. So that I can get rid of the absolute value. So I'm getting 1. So the limit exists. So let's say f has a removable discontinuity. So when it has a removable discontinuity, 1 and 3. 2 is not, the limit does not exist. What I'm doing is true about the function. I need to check at x equal 2. What will happen? The limit exists or does not exist? And it's equal to f of 2 or not? Limit x goes to 2 of this function. Very clear, the limit exists, which is 2 minus x, 2 plus x. This is cancelled, so we have 4. So the limit exists. F of x exists. What is f at 2? F of 2 equal 1, not equal to 4. So f is not continuous at x equal 2. Actually, f has a removable discontinuity. Because it's not continuous, but the limit exists. So f has a removable discontinuity. In this function, you talk about removable discontinuity at x equal minus 1. Let us do it. I have what? X minus 1 square over x squared minus 1, which is x minus 1, x plus 1. Yes. Okay. Which one of the statement is false? Not true, huh? False. Okay. So the possible discontinuity, point of discontinuity, actually, point of discontinuity where the function is not defined, x equals 0, x equal 1, x equal minus 1. Okay. I want to check which one, what are types of discontinuity we have. At x equals 0, it will be non-zero over 0, so we have infinite actually. We have infinite here, or non-removable. We say infinite or non-removable, who cares? Okay. At x equal 1, this cancelled and this cancelled. And you can substitute easily. So the limit exists. So this is removable. So the limit as x goes to 1 exists. What about minus 1? Minus 1, the limit does not exist because it will be non-zero over 0. So actually it will be infinite here. Or non-removable. Let me say non-R. So if has two vertical asymptote, yes, because all of these, they go to infinite. So it's yes. Removable at x equal 1, yes. Infinite x equal 0, yes. Infinite x equal 1, yes. Removable at this, no. So I need the false statement. Yeah. Has another removable at x equal 0. Okay. I know there is a problem with the limit of these ones. Know that the limit, as this goes to 4, this goes to n of the greatest integer of x. This does not exist. I know at x equal what? Yeah, at x equal what? Yeah. Yeah, I need the answer. Okay. Yeah. So the limit does not exist. So it means if we take, for example, x goes to 1. If you notice, these are non-integer. Huh? These are non-integer. Where this greatest integer, the limit will exist and equal to its value. So the only concern is about the integer values. So because of that, he put 1. So the limit for 1 from right of this function is equal to what? Limit is goes to 1 from right of this. Yeah. 1 from right, that will be 1. So that will be 2e 1 over 4. That's just a value. Who cares? Okay. Now 1 from left. What will be the limit? This one will goes to 0. Huh? So you notice if x goes to 1 from right, the greatest integer will go to 1. X goes to 1 from left, this integer goes to 0. So 2e to the power 0. So the answer is 2. So they are not the same. So the limit does not exist for this function, for 1. So it's not removable. None. So this is the answer. Because looking at the integer values. This one, just substitute it. It will be, it's just simplify it, I mean. So the points of discontinuity are x equals 0 and x equal 1. Very clear. This is removable and this is not removable. Now, because this is will go to a value, but this is it will go to plus or minus infinity. It depends right or left. So if I has a non-removable at x equal 2, no. Removable at x equal minus 1, no. I just have 0 and 1. Removable at x equal 1, no, it's not removable. Not removable at x equal 0, it's removable. So that means the answer. Look at this. If x equal this, then what? F has an unremovable discontinuity. Okay. I need to check the removable. The discontinuity at 2. For example, for sure, 2 is my concern. So I need to check the limit as this goes to 2 from right. Check the limit as it goes to 2 from left. If they are equal, I check f of 2. If they are equal, then it's continuous. If they're not equal, then it's not removable discontinuity. If the limit they are not equal to each other, left or right, then it's not removable discontinuity. Okay, what is this? From right, I have here, I have 3 minus x. That will be 1. from left. I'm dealing with this. That will be what? 2. They're not equal. So the limit does not exist. So for sure, it's non-removable discontinuity. So this is the answer. The value of C for each this function has a removable discontinuity. You want to check when it has a removable discontinuity. Removable discontinuity, it means the limit right equal the limit from left. Should be equal to each other to start with, but not equal if at 2. Okay, let me check from right. From right, it will be here. I'll do this first to find the possible values of C. I have what? 2C plus 8 equal. Now for this one, I'll substitute here for the 2 less. I have C squared plus 4C. So I have this equation. I have C squared plus 2C minus 8 equals 0. So I have C minus 4 or C plus 4, C minus 2, minus 8 to C, yes. So C equal minus 4 or C equal 2. Okay. What is F at 2? It is 6C. So I need to check now. C equal 2. What will be the limit as this goes to 2? Either I'll take right or left because they are the same. If I take, so it will be the function. Yeah, if I do the function, maybe better. What is the function? It will be C squared plus 2, not C squared. Unless I don't have C's anymore. So it will be 4 plus 2x squared, 6C. Not 6C, خلاص, 12. This is 2x plus x cubed, if x greater than 2. At x equal to, this is what? 4 plus 8, 12. This they have 4 plus 8, 12. Oh, so I want to check, is it equal to x equal? So the limit, as this goes to 2, of f of x, because I'm concerned with 2, that will be 12, and it's equal to f of 2. So that means f is continuous at x equal to. Now let me check minus 4. C equal minus 4. Let me check that. C equal minus 4. What will be f of x? C 16 minus 4x squared if x less than 2 minus 24 if x equal to. I have minus 4x plus x cubed if x greater than 2. The limit as x goes to 2 for f of x for this function. Yeah, it should be the same if you apply it in the numerator or denominator. I mean, in this function or in this, because you know that the limit are the same. So 2, I have 4, 16 minus, that will be 0. I have minus 8 plus 8, that will be 0. Yeah, but will be f at 2, it's minus 24. They're not the same. So f has a removable discontinuity at x equal, at c equal minus 4. So this is the answer. Yeah, I think this is the same problem. Maybe, yeah. Okay. Yeah. So this is no need. So this is the same problem. 6 and 6. Okay. Now let me do this, which is the end, the last one. For what values of b does the function has a removable discontinuity at x equal to 0? Removable discontinuity means what? The limit as goes to 0 from right equal. The limit as goes to 0 from left, but not equal f at 0. So what is the limit? As goes to 0 from right. So I take this function. It is minus b squared plus 2. Okay. What is the limit? It goes to 0 from left. So I take this function. That will be b. So these two should be equal to each other. but not equal. F of 0 is what? F of 0 is 1. So check this. Minus b squared plus 2 equal b. So I have what? B squared plus b minus 2 equals 0. I can simplify it. B plus 2 and b minus 1 equals 0. So I have b equal 1 or b equal minus 2. Okay. Now, if b equal 1, what is the function? It is 1 minus sine x, x less than 0. 1 if x equals 0. It is x cubed minus 1 plus 2 plus 1. X greater than 0. Now, the limit as x goes to 0 for this function is what? It's 1, 1 right or left, that is 1, and it's equal to f at 0. So it means f is continuous at x equals 0. I'm not looking for this. What about b equal minus 2? What will be f of x? Minus 2? Yeah, we have minus 2. That will be minus 2 minus sine x, if x is a negative, 1, if x equals 0, x cubed, minus 4 plus 2, minus 2, if x is positive. Okay, so what is the limit as it goes to 0 for f of x? It should be the same. I have minus 2 minus 0 and have 0 minus 2, so this is minus 2. And it's not equal to f at 0, which is 1. So it means f has a removable discontinuity. Sorry. When c equal minus 4 هنا. Has a removable discontinuity at x equal 2, huh? But when c equal minus 4, huh? So here we have removable discontinuity at x equal 0, but when b equal minus 2. So that will be the answer. Let me stop. Let me stop the recording. Then I will do another video later. Yeah. Thank you.